This video is about solving a proportion algebraically and solving a ratio and proportion application. So remember that similar figures are the same shapes that are with congruent angles and proportional sides. So proportional sides means if we take two dimensions of our shape and compare them, they're all going to reduce to the same fraction. So in number one, are the figures similar or not similar, and why or why not? So let's first look at the red triangle, and we're going to look at the height of the red triangle and the base of the triangle. So the height of the triangle is 3 because we have from 0 to 3, and the width will count from one end to the other end, so that gets us a width of 8. So our ratio of height to base is 3/8. Then we're going to do the same thing for the blue triangle. So the height of the blue triangle is 9, and the length of the base when we count is 16. So we have 9 over 16, which can't reduce. So because the ratio of height to base does not reduce the same thing, these shapes are not similar. So we would say no, because the dimensions are not proportional. In B, we're going to look at the length and the width. So when I look at IU, I can count and see that the height of IU is 6, and the width from S to U is 4. So we're going to do height to width, so I get 4 over 6, which reduces to 3 over 2. Then we're going to look at our other rectangle. So from A to C, this has a height of 12, and from C to H, this has a width of 8. So we have 12 over 8, which reduces to 3 over 2. So because they reduce to the same ratio, these are going to be similar figures. So we would say yes, because the dimensions, or we can say the sides in this case, are proportional. So scale factor versus similarity ratio. So scale factor is something that we've talked about the past couple of days and in past units. So scale factor is a number that we multiply to get the coordinates of the original figure by multiplying in order to find the coordinates of the image. So in this case, remember that the letters that don't have a tick mark is going to be our old figure, and with the tick mark is going to be our new figure. So when we're looking for scale factor, it's always going to be new over old. So we can look in the picture by looking at the A's and the A ticks marks letters, or in the sentence we have A, B, C is the old one because it's the first triangle, A prime, B prime, C prime with the little tick marks is the new figure. So when we compare those, we would take the same side of the figure, so in this case the BC's, and the new side is 8, the old side is 20, and that reduces to 2/5. The similarity ratio is the fraction you set up when you're comparing the actual lengths. So when we do similarity ratio, it's going to be our reciprocal. It's the old over the new. So we have 20 over 8, which reduces to 5 over 2. So in number 2, sketch the following situations and answer the given questions. So we're going to draw the two triangles A, B, C, and A prime, B prime, C prime. So A, B, C. They told us that AB is 4 and AC is 9. And then we have A prime, B prime, and C prime. So AC is 13.5 and CB prime is 24. So first, to find the scale factor, I need to see the side that has the number on both sides of the triangle. So AC and A prime, C prime have the numbers on both sides of the triangle together. So we're going to use those sides to find our similarity ratio. So your similarity ratio, remember, is new over old. So we have 13.5 over 9. To find our ratio, we're going to do 13.5 divided by 9. Math, enter, enter, to give us our fraction of 3 over 2. To get our similarity ratio, remember the similarity ratio is the old over new, or in this case it's just the reciprocal, so it would be 2/3. In part C, we need to find AB. So we're going to call AB x, and we notice that the x side goes along with the AB side. So when we're trying to find a side, we need to set up a proportion. So we're going to use the sides we already had. 13, we're going to use them in triangle order though. So I'm going to do the first triangle over the second triangle. So I know I have 9 over 13.5 for my yellow sides, and then I have 4 over x, and now I can cross multiply. So when I cross multiply, I get 9x equals 4 times 13.5, which is 54, and I can divide by 9, so x equals 6. In our second part, we need to find BDs, or BCs. So we're going to call BCY, and we know that BC matches up with B prime C prime, which is 24. So when I set up my ratio to solve, I'm going to use those same sides again. So I'm still going to use 9 over 13.5, and I'm going to set equal to, I'm looking for BC, so I need y over 24. So when I cross multiply, I get 13.5y equals 216. And when we divide by 13.5, we get that y is 16. So let's look at another example. So we're going to again draw our pictures. So we have triangle ABC, and we have triangle A prime, B prime, and C prime. So BC has a length of 28, CA has a length of 25, A prime, B prime has a length of 11.5, and C prime, B prime has a length of 14. So this time, the two sides in the triangle that match up with lengths are 28 and 14. So we're going to use those sides to set up our ratio. So in this case, our ratio again is, remember, new over old. So we have 14 over 28 to get the scale factor, which is 1/2. The similarity ratio then is our reciprocal, old over new, so we get 2 over 1. If you ever had to find the similarity ratio without the scale factor, in this case, remember, we would just do 28 over 14 and then reduce that to 2 over 1. So now let's find our missing side length. So first we're going to find the side length of A prime C prime. So we have AC length and we have A prime C prime length. So to set up our proportion, we're going to use the two sides that have numbers on them. So we're still going to use 28 and 14. And we're going to do 28 over 14, because I do the first triangle over the second triangle always, equals 25 over x. So when we cross multiply, we get 28x equals 350. We can divide by 28 on both sides, and we get that x is 12.5. And then the other side that we need to find is BA. So we're going to call BA x, and we know that BA corresponds with B prime A prime. We're still going to use 28 over 14 because that's the sides that have both lengths, equals, and in the first triangle we have x, and the second triangle we have 11.5. So when we cross multiply, we get 322 equals 14x, or we're going to call this y. Let's change this to y because we already had an x. So we'll say 14y, and we divide by 14, we get that y is 23.